Hello everyone. In this video we're going to be solving a polynomial equation. In other words, a golden problem. Why is it called a golden problem? We'll find out. So we're supposed to solve for x. We have the quantity x squared plus x plus 1 squared equals x squared times the quantity 3x squared plus x plus 1. If you expand everything, you're going to get a quartic equation from here, obviously. And that could be a little hard to solve. There are solutions for quartic equations. There's a formula, which is a little bit complicated. But we're going to be using a different approach. We're going to take advantage of the fact that we have an expression that could be turned into something else by way of substitution. So here's what I'm going to do. I'm going to distribute first, without expanding this, of course. Just the right-hand side, 3x to the fourth plus x cubed plus x squared. Okay. Now, I would like to divide both sides by x to the fourth power, and that is going to turn our equation into something easier to handle. Now, you might be asking, like, why are we doing that? Because it's going to turn it into something that we can use substitution with. So let's go ahead and divide both sides by x to the fourth power. Take this, divide by x to the fourth. Take that and divide by x to the fourth. Okay. Now, notice that the denominator can be written as x squared squared. So, in other words, this can be written as x squared plus x plus 1 over x squared quantity squared. And the right-hand side can be split up into 3 plus 1 over x plus 1 over x squared. Great. So far, it doesn't look meaningful maybe to you, but once you split the inside of the left-hand side, you're going to notice something interesting. When we split it up, in other words, divide everything by x squared, we get 1 plus 1 over x plus 1 over x squared. And you get something nice on the right-hand side, and now we can use substitution. And substitution involves that we call something else, right? Okay, so how do we do that? Let's go ahead and take this expression, this part, and let's call that u. Okay, that gives us 1 plus u quantity squared equals 3 plus u. Great. Let's go ahead and expand the left-hand side. You get u squared plus 2u plus 1 equals 3 plus u. Let's put everything on the same side. We get u squared plus u minus 2 equals 0. And this is factorable, obviously. We're basically factoring this trinomial, means looking for two numbers whose product is -2 and whose sum is +1. And those numbers are 2 and -1. Therefore, this trinomial can be written as u plus 2 multiplied by u minus 1 equals 0. Great. From here, we get two solutions. You could also use the quadratic formula, which wouldn't be too hard. But since it's factorable, we used factoring. So first solution I'd like to take a look at is u equals -2. This implies, because remember what we used u for, 1 over x plus 1 over x squared. This implies that 1 over x plus 1 over x squared equals -2. Let's go ahead and simplify this by multiplying both sides by x squared. That gives us x plus 1 equals -2x squared. Put everything on the same side, 2x squared plus x plus 1 equals 0. And interestingly, for this polynomial equation, we're not just interested in real solutions, we are interested in all solutions. Okay, so if you solve this equation by using the quadratic formula, you get -b plus minus the square root of b squared, which is 1 minus 4 times 2 times 1, and that gives you a complex solution, or complex solutions, because 1 minus 8 is -7, and the square root of -7 is not a real number. So from here we get x equals -1 plus minus square root of 7 multiplied by I all over 4. Okay, that is my first set of solutions. And then let's go ahead and take a look at the other set. The other set is going to come from u equals 1, which implies that 1 over x plus 1 over x squared equals 1. And then if you do the same thing, multiply both sides by x squared, you get x plus 1 equals x squared. X squared minus x minus 1 equals 0. And this gives us the golden flavor, the golden equation, the golden problem. And from here, x becomes negative b, plus minus the square root of b squared minus 4ac. That becomes 4 times 1, which is 5. And then we do get x equals 1 plus minus square root of 5 divided by 2. So that gives us another set of solutions. Along with the first set, let's go ahead and put it together. We get x equals this, or x equals negative 1 plus minus the square root of 7i over 4. And this basically gives us 4 solutions, 2 of which are real and 2 of which are complex. And this brings us to the end of this video. I hope you enjoyed it. Please let me know. Thank you for watching. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.